it gets harder. Okay, now we're going to take it up in little, like notches each time. Okay, but if you end up like today not knowing how to do it, that's going to really put you in a tough spot for when we're solving these. So we're going to first review how to do this with numbers, and then we're going to add in all of the x's and stuff. Okay, so fractions 101. When you are adding and subtracting fractions, you can only do it if they have what's called a common denominator. And so what that means is that the bottoms have to be the same. Okay, if they do have a common denominator, then you can add or subtract the numerators and combine over whatever that common denominator is. Okay, so if they have the same bottom, then you're allowed to add or subtract the tops. Okay, and then from there you would simplify. Okay, so this is what that means. Take a look at 1, 2, and 3. Okay, number 1 is 1 over 5 plus 7 over 5. So the first thing that you would check is, do the bottoms match? They're both over 5. So then I can make that 1 plus 7 all over 5. So if the bottoms match, I make it one big fraction, and then for the simplify step, what is 1 plus 7? So that'd be 8 over 5. Easy, right? Okay, take a look at number 2. Do they have the same denominator? Okay, they're both 12s on the bottom, so I can make it 5 minus 7 over 12, right? First thing I do is combine it into one big fraction, then second thing I actually subtract. So 5 minus 7 gives me negative, 2 over 12. Now that will actually reduce to be negative 1 over 6, but I don't need you to do that for today. You just have to be able to put them together. Okay, then look at the last one. They're both over 3. I have a common denominator, so I could make it 2x plus 5x over 3. And then 2x plus 5x on the top gives me 7x over 3. Okay? Alright, now let's talk about how to fix it if they don't already have a common denominator. So if they do not, you are going to create a common denominator by considering the least common multiple. Okay, basically what that means is that you need to find the smallest number that both of the bottom numbers can multiply to be so that they match each other. Okay? When you multiply a number in the denominator, you must also multiply that number in the numerator. Then from there, you're going to add or subtract the numerators over the common denominator. I'm going to just abbreviate that CD, and then you're going to simplify. Okay? Morning. Okay, so take a look at number 4. Now I'm going to write this a little bit bigger just because I write really big, but you probably don't need to rewrite this. So if it's 7 over 6 plus 2 over 3. Okay, first question. Look at the denominators. Do they match? No. We want them to match each other though. So if this is a 6, is there anything that I can times 3 by so that it will match? 2. But if I'm going to times by 2, I can't only do it on bottom, I have to also do it on top. So I'm going to times this by 2 and by 2. Now remember, the reason we pick 2 is so that the bottoms will both be the number 6, yeah? Okay, so from here now, I have 7 over 6 plus, and then for my fraction, 2 times 2 on top, this is now what? 4 over 6. And so then that means I'm allowed to put them together in one fraction. What is 7 plus 4 across the top? 11 over 6. And that's your answer. Okay? Come down to number 7. We're going to do number 7 next. Okay, I'm going to write it a little bit bigger. So it's 3 over 10 minus 7 over 30. Okay, look at it. Can I make one of the bottoms match the other bottom? Yes, what do I need to times, the first or the second fraction? Okay, it's a 10, I need it to be a 30. What do I times by? 3 on top, 3 on bottom. Okay, then for the top, it's a 3 times 3. That makes how many? 9 over 30 minus, and then 7 over 30. 9 over 30 minus 7 over 30 is 9 minus 7 put together over 30. And this is this step that probably most of y'all can skip. You can just subtract it. That's fine with me. Okay, but I make it one big fraction because they have a common denominator, and then 9 minus 7 is 2 over 30. Now, if you're comfortable with reducing that to 1 over 15, okay, perfect. That's good. But it's not necessary. You should know how to do it for SAT, ACT, that kind of stuff, but you won't get points off if you don't do it today. Okay? All right, now, next one. Take a look at number 5. Number 5 is a little bit different. So I have 5 over 2 minus 7 over 3. Okay, is there any number that I can times the 2 by so that it will be a 3 as well? No. Is there anything I can times a 3 by to turn it into a 2? No. Then you're going to have to times both of them. This is where the least common multiple comes in. You want to pick the smallest number that they can both times to be so that they match. 6. Good. The easiest way to find that number is to just times the numbers together. So 2 times 3 is 6. Okay, then I need them both to be a 6. What do I times the first fraction by? 3 over 3. And what am I going to times the second fraction by? 2 over 2. Okay? And then from there, you'll rewrite your fraction. They should now have a common denominator, and then you can put them together. So for my first fraction, it's a 3 times 5 on the top. Now that's a what? 15 over 6 minus. Then I look at my second one. 7 times 2 is a 14 over 6. And now that they're both over 6, I'm allowed to subtract those tops. So 15 minus 14 is how many? 1/6. Good. Okay, take a look at number 6. Okay, again, I do not have a common denominator right off the bat. There's nothing I can times 3 by to make it a 5. So I'm going to have to times both of them to find the least common multiple. So if the first one's a 3, the second one's a 5, what's the smallest thing they can both be? 15. So I'm timesing by 5 over 5 and 3 over 3. Okay? What will my first fraction become now that I've gotten a common denominator on the bottom? 10x over 15 plus. And then for my second factor, I times by 3 over 3, so now that's a 12 over 15. 12x over 15. And then 10x plus 12, yes sir?
How do you know you're adding and subtracting?
You know based on the sign in the middle. So if it started off as a plus.
But it doesn't change like once you bring it down or anything like that?
Nope. Nope. Good question. You don't have to do any switching for now. Okay, and then from here, 10x plus 12x gives us 22x over 15. Okay, got it? Okay, so it's about to get a little bit harder because we're going to start putting x's in it. The first one, though, is not so bad. These are easy if the bottoms already match. So look at the next example. Okay, I know the hole punch took it out. Okay, but for number 8, do the bottoms already match? 2x squared plus 1 and 2x squared plus 1. If they already match, then your new answer is going to be over 2x squared plus 1 as well. And then what do I do at the tops? Add or subtract since I already had a common denominator? Add because there's a plus in the middle. So 3x plus 7x is 10x and you're done. Now I'm going to put a little star here and say this one already had a common denominator. Okay, so that's why that one was just kind of like already, it was basically done. Okay, so here's how you're going to do it if they don't have a common denominator. And actually, I think all of these steps are the same. Okay, so we're not going to go back and rewrite those. Go ahead and turn the page. Let's look at the next example. Okay. So, top one. Okay, look at the bottoms. Do they already match or no? No, they don't. So we're going to have to make a match. So, looking at the bottom, I'm going to rewrite it a little bit bigger. 7x plus 30 over 2x minus 5 plus 5 over 2. Okay, look at the denominators. What do they have in common already? They both have a 2, so that's a good start. This one has an x plus 5, this one doesn't. That has to be fixed. When I multiply by x minus 5 on the bottom, where else do I need to multiply it by? On the top, so x minus 5 here, x minus 5 here. Now, do the bottoms match? Yes, then I can make it one big fraction over the bottom. So I'm going to make it something over 2x minus 5. Now, let's see what we're adding on the top. My first top is 7x plus 30 plus, and then when I get to the other top, what am I going to have to do if the 5 is outside the parentheses on the x minus 5? Distribute. Very good. So 5 times x is 5x, and then 5 times minus 5 is negative 25. And then after you do that, you're going to only combine like terms. That means that x's go with other x's, non-x's go with other non-x's. So if I have a 7x and a 5x, how many is that together? 12x. And then what is 30 if I take away 25? Plus 5. Now, on the bottom, I do not want you to factor it, or to distribute it. So just leave the bottom alone. So I have a 2 and an x minus 5, and you're done. Now let's talk about why are we distributing the top and not the bottom? Because on the top, I'm actually trying to combine stuff. Versus on the bottom, I'm not trying to combine anything, I just need them to match each other. Okay? Alright, take a look at number 13, please. Okay, I'm going to put 1 over x plus 3 plus 5x over, and then don't write the bottom. Okay, we are going to have to break 3x plus 9 down just like we would have done last week. Remember, your choices for breaking things down are GCF, perfect squares, and T-chart. So looking at the bottom right here, what method is this one going to be? GCF. What can they both divide by? Okay, so I'm going to put right here, GCF divide by 3. When I divide by 3, it was a 3x. So 3x divided by 3 is just an x. And then what about 9 when I divide it by 3? Plus 3. Okay, now look at the bottoms. Now that they're broken down, I can see what they already have in common. So they both have the x plus 3, but what do they not both have? The 3 on the outside. So I'm going to come to my first fraction. I'm going to put a times 3 on the top, and I'm going to put a times 3 on the bottom. Now, when I write that times 3 on the bottom, I want to make sure to put my parentheses there so that these guys match exactly the same. Yeah? Okay, so now I have this one big fraction. 3x plus 3 is what's on the bottom. And then on the top, I'm going to multiply out and add my stuff together. So what is 3 times 1 here? 3 plus, over here, 5x. Now, remember, for adding and subtracting, you can only do like terms. Are 3 and 5x like terms? No, because the 3 doesn't have an x, right? So you're done. Okay, so I'll put a little star here. If like terms, then combine. Okay, but since 3 and 5x are not like terms, I don't have to worry about that there. Okay? Alright, come down and take a look at number 14. Okay? So I'm going to go ahead and break it up just like I did that one. Now remember, you're really only breaking up the bottoms for these. You do not have to break up the tops. So my first one is x plus 2 over x plus, My second one is 2x squared minus 3x over 4x times x. Okay, looking at the two bottoms, one of them is missing something. They both have 1x, but what does this first fraction need so that it can match? It needs another 4x. Okay, so these are already in common, but I have to put this on the other fraction. And when I put it on the bottom, I have to also put it on the top. Okay? So now look at your denominators. Do they match each other? Okay, then we can combine into one big fraction. So I'm going to have 4xx on the bottom, or 4x squared. But on the top, when you see those parentheses, you're going to have to do some distributing before you can combine like terms. So what is 4x times x? 4x squared. And then what is 4x times plus 2? 4 times 2 is 8x. Okay, then I'm going to write my other top over here. 2x squared minus 3x. Okay, then from there, now that the parentheses are gone, I can only combine like terms. That means the x squareds can go together, the x's can go together. So if I have 4x squared plus 2x squared, how many is that all together? 6x squared. Okay, then I have an 8x and a minus 3x. How many is that? 8 minus 3 is 5x left over. And then on the bottom, if you want to leave it as 4xx, that's not wrong. Okay, but I'm just going to leave it as a 4x squared. Make sense? Okay, let's jump down to number 16. We're going to come back to number 15. Okay, come down to number 16. Take a look at it. Okay, I have 6x minus 10, x plus 5x minus 1, x plus 5. Okay, look at the bottoms. What do they already both have? Numbers, there's two number 16s. They both have x plus 5s. So I'm going to put a little check. These already match. So what's the problem? What are we missing? The x minus 1. If there's an x minus 1 here, there's only a common denominator if there's also an x minus 1 here. Okay. And so then from there, remember, once the denominators match, you can combine it into one big denominator. So it'll be x plus 5 and x minus 1 on the bottom. And then on the top, I'll do 1 plus the other. So on top here, I have 6x minus 10 plus. And then what will I have to do on this other fraction? Because of the parentheses, distribute. So x times x is x squared. And then x times minus 1 is minus 1x. And then from there, you're looking for those like terms to see which ones can go together. Okay, are there any like terms on the top? There's one set. Which two? The 6x and the minus 1x. Very good. And what is 6x minus 1x? 5x. Now, one other thing that I'm going to do here, and this isn't wrong if you don't do it, okay, but I'm going to put them in order. So I'm going to let the x squared come first. Then 6 minus 1 is going to give me 5x and then minus 10. And that would be your answer. Okay, but you do not have to put those terms in order. That's just how you'd see it on like SAT, ACT, that kind of stuff. Okay? Alright, one more like that. Take a look at the problem right next to it. So it's 6x minus 8 minus x minus 4 over. Okay, now this bottom piece right here, we're going to have to simplify. Okay, when stuff isn't factored, it's hard to tell what's missing. So if this is x squared minus 64, what kind of factoring is that? It's square root, perfect squares, very good. Okay, what is the square root of x squared? x. So I'm going to put an x and another x. And then what's the square root of 64? 8 plus or minus 8, right? So I put a plus 8 in this one. I put a minus 8 in this one. And then I look at my fractions to see what do they both already have, and then what do I need to fix so that they both already have it. So I see they both have the minus 8, but my first fraction needs this plus 8. So I'm going to put an x plus 8 here, and an x plus 8 here. Now, it is not important that the terms are written in the same position on the bottom as long as they're both there. So I see they both have an x plus 8 and an x minus 8. So I'm going to write that down here on the bottom. And then on the top for that 6, you're going to have to distribute. So 6 times x is 6x. 6 times 8 is 48. Okay, now this is important. We haven't done an example like this yet. What am I doing with the tops? Adding or subtracting? You're adding, right? Okay. Or actually, hold on. On the other ones I was adding. What am I doing on this one? Subtracting. Okay, if it's a subtraction, you have to distribute this minus sign into the top. This is why. If it's a plus 1, do I have to distribute a plus 1? No. But if it's a minus 1, you do. So I'm going to have a minus on the x, and then a minus on the negative 4. So is that going to stay a minus 4? Now it's a plus 4. So if you are subtracting, you have to apply that subtraction to both of the terms in the second fraction. Or if there were 3, you'd apply it to all 3. Okay? Then from here we're combining like terms. 6x minus an x is 5x. And then 48 plus 4 is 52. Okay, then I have x plus 8 and x minus 8. Okay, now just in prepping you for the SAT, PSAT, that kind of stuff, how else could they have written the bottom? They could keep it broken down, but could they also put it back together into x squared minus 64? Sure, they could. Okay, so I'm going to put an or on this one. Could be 5x plus 52 over x squared minus 64. Okay, because remember, that plus 8 minus 8 has a special little version of itself like this. So these are the same. I'm fine with this one, but if you see it on a standard test or something, it may be written like that. Okay? Alright, the last one. Rewind back to number 15, please. The reason that we skipped number 15 so far is that do they already have anything in common? No. On top, I have 5 on the first fraction and an x minus 4 on the second fraction. So the problem is that these do not have anything in common right now. But remember, I can fix it. Okay, what does the first fraction have on the bottom? A 5. So then I'm going to put a 5 here and here. Okay, now they both have a 5. What does the second fraction have? An x minus 4. So then if that one has an x minus 4, I need to put an x minus 4 here and here. And so now I had to fix both fractions, but the bottoms match. So they both have an x minus 4, they both have a 5, so I can make it a 5x minus 4 on the bottom, now that they both match. And then instead of only having to distribute in one of the fractions on top, you're going to have to do it on both. So I wrote this kind of in a weird order, but you're still distributing, you're just distributing from the right side. So what is x times x? X squared. What is x times minus 4? Minus 4x. Okay, good. Now, on my second fraction, what am I distributing? Not just a 5, a minus 5. Because remember, if it's subtraction, you have to distribute that negative as well. So it's negative 5 times x is negative 5x. And then negative 5 times negative 2 turns into a plus 10, positive 10, good. And then from there, you look to see if any of the guys are in common with each other. The only two that are in common are those middle two in here. If it's negative 4 minus 5 more, that gives me negative 9 in the middle. So you'd have x squared minus 9x plus 10, 5x minus 4. Okay? So you can only add or subtract when you have a common denominator. If there's already a common denominator, you're good to go. But if there's not, you may have to fix it so that there is one. Okay? So you have about 20 minutes. Take a look at your homework. Okay, let me see if there's any on here that we might need to go over. Yeah, pretty self-explanatory. Okay, why don't we do, let's just run through a couple of them. Number 2 at the top. Okay, let's do one of the number ones. Okay, do they have the same bottom on number 2? No, we're going to have to fix it. So if this is a 5 and this is a 2, I can't make them match each other unless I change both of them. What is 5 and 2's least common multiple? Okay, I want to get a 10. Very good. 5 times 2 gives me 10. So I'm going to times by 2 on top here. I'm going to times by 5 on bottom here. Okay, and then I'm going to put over here LCM equals 10. Okay, because that's the least common number that they can both multiply to. So 2 times 7 on top, what do we get? Okay, that'd be 14 over 10 minus. And then 4 times 5 here, how many is that? 20. Okay, and then since they're both over 10, I can subtract the tops. What is 14 minus 20? Very good. Negative 6 over 10. Okay. Oops, I forgot to put the over 10 on that middle one. Okay, now I do not care if you skip this step. That's fine with me. Okay, as long as you know how to do it. If you want to skip that, that's totally okay if you want to. Okay, let's come down and take a look, please, at number 6. Okay, you're going to have to break down the bottom on number 6. Notice that, actually, let me ask a question here real quick. On number 4, are you going to have to break down the bottom of that? Why not? They already match. If they already match, you don't have to break anything down because they're already good to add up. Okay, now on number 6, are you going to have to break it down? Yes. Specifically, you're going to have to break down that one. So look at it. It's an x squared minus 4. Okay, what type of factoring is that going to need? Okay, what do they both have in common? Does the 4 have an x though? Nope. Okay, they don't have anything in common, then what's my only other option? Perfect squares, right? What's the square root of x squared? The x, right? And then what's the square root of 4? Plus or minus 2. So I'd have an x plus 2 and an x minus 2. Okay, then look at your bottoms. They already both have the x plus 2, but what does the second one need? It needs the x minus 2. Okay? And then from there, I'm not going to finish this one, but what are you going to distribute in that second fraction? What are you going to distribute in there? The negative x. Very good. Make sure, circle it, and put arrows. Okay, we're going to do one more off the back, but you're going to have to distribute the minus with the x. You have a question? Just stretching? Okay. Flip over to the back. We're going to do one more that has a T-chart on the bottom. Just since there wasn't one of those on the notes. Which of those has a T-chart on the bottom? Number 10, right? Hello? I do. Sure. I'll send them in just a minute. Thank you. Bye. Okay, so take a look at number 10. Okay, I want you to T-chart this one. Right here. And then GCF that one. So let's do the T-chart first. What goes at the top of my chart? 2? What's the only way to times to get 2? Okay, 1 times 2. Does that also add to a 3 in the middle? Yes, so over x over x. Okay, so that one's done. So I have 10x over x plus 1, x plus 2, right? Minus 5 over. Okay, now look at your second bottom. It's an x squared plus x. What do they both have in common? An x. Very good. So I'm going to divide by an x. My x is going to come to the front here. And then I'm going to have to put whatever's left over once I divide that x out. Well, if it was an x squared and I divide by x, that leaves me with an x. And then this was a plus 1x. You can write the 1 in there if it helps you. But if that's a 1x and you divide by x, then what do you get? Sorry. What would you have left over when you take the x out? Plus 1. Okay, now look at the bottoms. What do they both have? They both have the x plus 1, but you're going to have to fix things on both of these. Okay, so look at the first fraction. I have an x plus 2. I have to give the second fraction x plus 2, but I can't only put it on the bottom. I have to also put it on the top. So I'm going to put an x plus 2 here and an x plus 2 here. Okay, I'm going to have to do that one as well. So what does the second fraction have that the first fraction doesn't have? He has this x, right? So I'm going to have to times by an x here, times by an x here. So on this one, you end up actually having to have 3 things on the bottom to help them match. Okay, they both already had this, but the first fraction needed an x to match, and the second fraction needed an x plus 2 to match. So for this one, how many things need to be on the bottom for them to be the same? 3. Okay? You need the x plus 1, and the x plus 2. Okay? So let's write out what we have here. X plus 1, x plus 2. Now I have one big fraction instead of 2 separate ones. Okay, then on the top, remember you're multiplying. What is x times 10x? 10x squared minus. And then I'm going to distribute the minus 5. What is minus 5 times x? Okay, minus 5x. And then what's minus 5 times 2? Yep, minus 10. Now, if any of those top guys could go together, I'd put them together. But since they can't, I just leave it. Okay? Alright, let's do one last one here. Let's do number 7. Top left-hand corner. Okay, number 7. Okay, first question, looking at the bottom. How are we going to factor this side right here? Is it perfect squares or GCF? It's GCF. Even though 9 is a perfect square, they have something in common. What do they both have? They can both divide by x. So you want to be careful about just because it's a perfect square, it doesn't mean that's how you're going to factor it. Okay, so I'm going to have 5x squared over. My x comes out to the front. What's left over from the x squared minus 9x? X minus 9. Very good. Plus 3x over x minus 9. Okay, then you look at the bottoms to see what do they already have in common, what do I have to fix. Okay, they both have the x minus 9, what do I need for them to match? Yes?
How do you know whether the GCF or just x squared if they're the same?
Based on if, so here's the difference. This one, do you see how they both have an x? They have something in common. Now look at this one. Almost the exact same problem, but the 9 does not have an x. This one you're going to have to do square roots on. So if they have something in common, it's automatically GCF. But if they don't both have an x, GCF is out, you'd have to do square roots. Okay? So for my first one, I have an x here. I need to put an x here. And I need to put an x here. So now, do the bottoms match? Yes. I have a 5 and an x minus 9. I'm sorry, I said that wrong. I have an x and an x minus 9. But then on the top, I'm going to have to actually combine that into one big top instead of two separate ones. So I have my 5x squared from here. I didn't have to change that one at all, plus. And then if it's 3x times x, that's a 3x squared. And then if they're like terms, you want to put them together. Are they like terms? Yes. 5 plus 3 gives me 8x squared over x minus 9. Got it? Okay, you want to do number 8 together? Last one? Okay, look at the bottom. How can we split that up? We already kind of said it. That one's going to be perfect squares. So I'm going to break that up. 3x over. And remember, perfect squares is a shortcut. When I square root x squared, I get x. I square root 9, I get plus or minus 3. So it's x and x, one with a plus 3, one with a minus 3. Okay, symbol in the middle is a subtraction. And then I need to factor the bottom of that one. Okay, is that going to be perfect squares or GCF? GCF, because what do they have in common? They both have an x. So I'm going to put GCF divided by x. X comes to the front. What's left over? X plus 3. Very good. Okay. Then you look across the bottoms. What do they already have in common? And what do you have to fix? Okay. What do they both have already? X plus 3 is good to go. What does the first fraction need so that it matches the second fraction? It needs this x, right? So I'm going to put an x here. I'm going to put an x here. Okay, what does the second fraction need that the first fraction has? I need the x minus 3, right? So I'm going to put an x minus 3 here and an x minus 3 here. Now, again, I think I said this earlier, but just in case you forgot, it doesn't matter if you write the bottoms in the exact same order. As long as the same crap is there, it doesn't matter. Okay, so one big fraction here. I have an x plus 3, and an x minus 3 across the bottom. And then on the top, you have to remember to multiply and combine like terms. So what is 3x times x? 3x squared. And then what am I distributing on top here? Just a 2? A negative 2. Very good. Negative 2 times x is negative 2x. Negative 2 times negative 3 is a plus 6. And then if any of those guys could go together, you would do it. But that's an x squared, that's an x, that's just a 6, so you're done. Okay, but if they were like terms, then you'd have to do it. Make sense? Okay. Alright, you have a couple left. And then if you came in late, test corrections. If you need to correct your test from last week, are after school today, tomorrow, and Thursday. From Friday. Can you finish it today after school? Or during lunch? Huh? B-lunch is good. I have all of the lunches off, so that's my conference period. Just don't forget, because I'm going to grade it tonight.